show that the given matrix has complex eigenvalues, find the eigenvectors of the matrix. So here's the matrix A, and you need to show that this has a complex eigenvalues, then find eigenvector for it. So to find the eigenvalue for this one, first you need to find A minus lambda I, which is this. So what is lambda I? Lambda I is lambda times the base matrix. Okay, so which is this. Now after you have lambda I, you take this, subtract this, that gives you A minus lambda I. Now and then you find the determinant of A minus lambda I. Okay, so you have -1 minus 1 times 1 minus negative lambda minus 2 times -5. Okay, so simplify this, that gives you lambda squared plus 9. Set this equals 0 and then solve for lambda. You will get lambda equals plus and minus 3i, which is imaginary solutions. Okay, now you need to find the eigenvectors for this one. Okay, so for the first case, when lambda equals positive 3i, plug it into this one. That gives you 1 minus 3i to -5, 1 minus 3i augmented with 0. Okay, and then simplify it down to base matrix using Jordan elimination. Okay, so before I do that, because I don't want to work with imaginary number I, first thing I need to move this row up and this row down. Okay, so after I did that, I got this one. So it's basically just switch the position of the first and second rows together. So I got -5 on the top now. Now the next step is to divide this whole row by -5 to get 1. So -5 divided by -5 positive 1. 1 minus 3i divided by -5, and then okay, so let me show you why I got that one. Okay, so if I have 1 minus 3i divided by 5, and I can split it, -5, I can split it out into two fractions. Okay, so I have 1 over -5 minus 3i over -5, right? So this is -1 over 5, and this negative become positive 3i over 5. Okay, so that's why I have this one. Alright, now for this row, just rewrite it. Okay, and then I got 1 for this one. Now to make this become 0, multiply this row by 1 plus 3i and add it up onto the second row, which I already noted here. So after I did that, I got 0, 0, 0. Okay, so you have indefinite solution. Okay, so from this one, I have k1 equals 1 minus 3i over 5 k2, or k2 equals 1 plus 3i over 2 k1. Right? Well, yeah, instead of doing all of these matrices, I can do it at the beginning because you know that this is k1, this is k2, this is 0. So -1 minus 3i times k1 plus k2 equals 0, and then you solve for k2, that gives you this one. If I have -5k1 plus 1 minus 3i k2 equals 0, solve for k1, I got 1 minus 3i over 5 k2. Okay, let me show you what I meant by that. It's a little bit confusing here. So for this one, I have -1 minus 3i k1 plus 2 k2 equals 0, and then you solve for k2, which gives you this one, right? It's very simple. Now for this one, -5k1 plus 1 minus 3i k2, set it equals 0, and then you solve for k1, that gives you this one, what I circle in red. Okay, makes sense. Now from this, if I choose k2 equals 5, for this one, if I choose k2 equals 5, I got k1 equals 1 minus 3i. Okay, and then my eigenvector for it is 1 minus 3i 5. You can choose k1 equals 2, and then you will get k2 equals 1 plus 3i. Okay, alright, now you are going to do the same thing for lambda equals negative 3i, plug it into here. So for lambda equals negative 3i, plug it into here. I got this new matrix here, down here, and then augment it with 0. Alright, go and using this strategy, I have negative 5 k1 plus 1 plus 3i k2 equals 0, and then I solve for k1. That gives me 1 plus 3i over 5 k2. Okay, if I choose k2 equals 5, I got k1 equals 1 plus 3i, and then my eigenvector for it is 1 plus 3i 5. Okay, alright, here's the thing. Now if you notice, for a complex eigenvalues, you will have one positive and one for negative for the imaginary number, right? So for this one, if you have 1 minus 3i, the other value should be the other value for other eigenvector would be 1 plus 3i. Okay, 1 negative, 1 positive. Okay, if you know that, you don't have to go over this step. Alright, that's it.
If you find the video is helpful, feel free to give it a like, share, and subscribe to my channel in order to receive the most current videos. Don't forget to hit the bell so that you won't miss anything. I'll see you next time.